Dear children, we are going to solve the first numerical problem of this unit motion. Solving the numerical problem is damn easy. First of all, keep this in your mind. First, read the question. Second, draw a diagram according to the question. Third, write the formulas and apply the concepts. You can get the result. That's it. So first of all, what I'm going to do is to read the problem. An object travels 16 meter in 4 seconds and then another 16 meters in 2 seconds. What is the average speed of the object? We have learned what is speed and average speed. Now, first of all, I'm going to draw a diagram. So this is the point A. From point A, the object travels to 16 meters to point B in 4 seconds. So the distance traveled is 16 meters and the time taken is 4 seconds. Let that point be B. From there, it is traveling another 16 meters for another 2 seconds. Now, the first distance be S1 and the first time be T1 and the second distance covered be S2 and the second time covered be T2. That's it. We have almost solved the problem. It's very clear. Now we are going to do write the formula. What is the average speed? V average is equal to total distance covered divided by total time taken. So what would be the total distance traveled? That would be V average is equal to S1 plus S2. Simple. Time taken T1 plus T2. What is S1 plus S2? 16 meters plus 16 meters divided by 4 plus 2. That is 32 divided by 6. That would be around 5.33 meters per second. So that's very important. Distance is measured in meters and time is measured in seconds. So the unit of speed is meter per second. That's it. We have solved the problem. Is it not easy? Yeah. Now, after understanding the concept speed, we are going into velocity. Velocity is the speed in a particular direction. As you already said, distance is a scalar quantity. It has only magnitude, but displacement has magnitude and direction. Likewise, speed has only the magnitude value, but velocity has the direction. So speed plus direction is velocity. That's it. Distance is the distance covered, but displacement is the distance covered with direction. So from point A to B, 20 kilometers is a displacement because that is the shortest distance. But somebody moves in the green color path and goes and travels 50 kilometers. Now the displacement is A is 20 kilometers north of B. Now that speed plus direction is called velocity. It is also measured in meters per second. Now we are coming into the another topic, that is average velocity. What is average velocity? That is initial velocity divided by final velocity divided by 2. Initial velocity is mentioned as small u, final velocity is mentioned as small v. So that is, so how do we understand the speed and velocity in our real time and in our real life? So you are coming from your home. You are traveling in the bike or you're traveling in the bus at some speed, at some velocity. And you're taking this much of, you are starting at 8 o'clock and you're reaching the school at 8:30. So you can calculate the distance. So this is where we apply what we study. And so if you know the distance, you can calculate your speed. If you know the speed, you can calculate your distance. Simple. Yes, B is equal to S divided by T. That is the basic formula that I have told. What is another example? Now that we have good rain around Marinagar, you might be wondering, you might have seen a lightning, but after some time we are hearing the thunderstorms. That's happening at the same time in the sky. But why do there is a delay? Does that not wonder you? Have you asked this question any time in your life? You should ask this question because speed, the light travels faster than sound. That is one point. So, if we know the speed of the sound, speed is known, and after the lightning, you know, after 5 seconds or 10 seconds, you may hear the thunderstorms. So, you know the speed of the sound, you know the time after that you're hearing the thunder. You can calculate the distance between you and the cloud. Yes, distance, time, and speed. You know that, and you can calculate it. So it is very, very applicable to our day-to-day life. This is not we are not studying something, some abstract concepts. Daily we are traveling. We are traveling in the bus. We are traveling in the bike. We are seeing the speedometers. So wherever you see, you are seeing the signboards. So you're moving always. You are running. So there is speed. There is time. Without time, we cannot live. There is time. That is speed. There is distance. So whatever you see in and around you, that is physics here. You can try the example 8.2. That's very easy. You check what is there in that question. I want you to do by yourself. Here, now I am coming to the next numerical problem 8.3. As I've already said, read it, draw the diagram, apply the formula, you solve it. You already solved. Now, Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the straight path. Find the V average, what is this? Average speed and average velocity. Now you might have understood. Now, what is the first thing we are going to do by solving the problem? First thing, we are going to draw a diagram to understand what is there in the question. So that is the swimming pool. That's not a swimming pool though. You imagine that is a swimming pool that is 90-meter long. Usha is there. She is swimming from one end to the other end. Yes, she's traveling 90 meters this side and she's coming back to the initial position. So she covers 180 meters. That's it. And oh, what is the other thing that is given? Yes, we can calculate and the time is given 1 minute. So distance traveled is 180 meter. Then what is the time? Time is equal to 1 minute, that is equal to 60 seconds. Now what we are going to do? Average speed. What is average speed? Total distance traveled divided by total time taken. What is the total distance traveled? 180 meters. Total time taken. Total distance traveled is 180 meters, but time is in minute. So we have to convert that minute into seconds because the unit of speed is meter per second. So 1 into 60. 1 minute is equal to 60 seconds. So I'm converting the minute into seconds. That's it. 3 meter per second. That is the answer of the average speed of Usha. Now we are going to calculate a very interesting thing. What is the average velocity? It looks both are one and the same, but that is not. Now you should remember what I have taught you. The formula is u plus v divided by 2. U is initial velocity, v is final velocity divided by 2. There is another formula, that is displacement by time taken. Okay, there's another formula. Okay, now we are going into a very interesting part of this problem. So Usha travels from here to here, and she goes back to here. So is there any displacement? The displacement is 0 because she is going back to the same position. So displacement is 0, so the velocity is 0. Even though the speed is 3 meter per second, the velocity is 0 meter per second because there is no displacement. She comes back to the original position. Now we are again going into the next part of this lesson, acceleration. Acceleration means rate of change of velocity. So if there is a uniform motion means if I am starting at one speed, if you're going in a highway, that's a uniform motion because the velocity is constant, the speed is constant. You are going at 60 km per hour. You are going at 60 km per hour. Nobody stops you in the highway. So velocity is constant. So there is no change. But in a non-uniform motion, you are coming from Maraimal Nagar to school, you cannot come at the same speed. There is a railway gate, there are many humps, there are many turnings. So you have to slow down at some point and you have to go fast at some point. So the velocity, the speed varies with the time. So the change in velocity per unit time is called acceleration. Change in velocity. So acceleration small a can be defined as v minus u. V is the final velocity, u is the initial velocity. So the change in velocity divided by time taken. It can be easily understood by this example. So you are going in the highway. You are going at 60 km per hour. So while you are overtaking a vehicle, you will give acceleration. If you are going in a two-wheeler, you will give a wrist action, acceleration. Or if you are going in a car, you will press the accelerator so that you can overtake a vehicle. So you are moving fast. You are not moving at constant speed or constant velocity. You are moving fast. So it is acceleration. You are overtaking. After overtaking, you are gained at some speed, 70 km per hour. You are moving in 70 km per hour. So immediately somebody comes, or immediately there is a vehicle. You are put on the brake. So 70 km per hour comes to 10 km. Immediately you stop. That is called deceleration. That is negative acceleration. So acceleration means when the rate of change of velocity is high, positive, that is called acceleration. When the rate of change of velocity is low, in the opposite direction, so that is called deceleration. Now there is another problem which I have already solved. Starting from a stationary position, Rahul paddles his bicycle to attain the velocity of 6 meters per second. So starting point Rahul is at rest. So U initial velocity is 0 meter per second. So in 30 seconds he reached 66 meter per second to this point. After reaching this point, he applies the brake such that the velocity of the bicycle comes down to 4 meter per second. So it comes to 4 meter per second. Initial velocity u is equal to 0. Final velocity v is equal to 6 meter per second in the first case. So what is acceleration of the bicycle in both cases? So we have drawn the diagram. Rahul at point A, Rahul at point A moves to point B, say this is point B, and after that from there he applies brake and come to point C in 5 seconds. I have drawn the diagram, that's all. Acceleration is equal to v minus u divided by t. What is v? V is the final velocity in the first case. The first case. This is the final velocity. The final velocity in the first case is 6 meter per second minus 0. What is the initial velocity when he is starting? He is at rest. So initial velocity is 0. 6 minus 0 divided by what is the time taken? 30 seconds. So 30 seconds will give you 0.2 meter per second. In the second case, here his speed, his initial velocity is 6 meter per second. In the second case, from 6 meter per second, he is going at 6 meter per second. Immediately applies brake. So in next 5 seconds, it comes down to 4 meter per second. That is the final velocity in the second case. So acceleration is equal to v minus u divided by t, that is 4 meter per second, that is the final velocity, minus v minus u, initial velocity is 6 meter per second, that gives you, divided by 5 gives you minus 0.4. So what this plus 0.4 and minus 0.4 means, plus 0.2 gives, that is an acceleration, there is a speed increase. Minus means there is a speed decrease. Rate of change of velocity. The rate of change of velocity is low. Here the rate of change of velocity is high. So this is acceleration, this is deceleration. Now I would like to appreciate the people who have got third prize. That place Jackson, Anto, Ruchita, Deepan, Vidya, Pushan, Catherine and Subhashri. Thank you and lot of appreciations to all. Now I will give some problems in the Google Forms. Solve it smart, fast, and let me know the prize winners of the next class. Thank you. Bye.